Hey everyone, today we'll be calculating the pHs of weak acids and bases. So to calculate the pH of a weak acid or a weak base, we have to take the dissociation constants into account, and they're just a measure of the strength of an acid or base, and they're just normal equilibrium constants applied to acids and bases. So let's calculate an acid dissociation constant. So let's say we have hydrofluoric acid, which is going to dissolve into H plus and F minus. So yeah, it's just a normal equilibrium constant. So we multiply the concentrations of the products and divide that by the concentration of the reactant. And there we have it. Yeah, it's the same thing applies to the base dissociation constant. So let's do ammonia plus water equals pneumonium and hydroxide. So we're just going to do the same thing, concentration of products, multiply them, divided by the concentration of the reactant. And there we go. And we don't take water into account. And there's one last constant we have to worry about, the water dissociation constant, which is always going to be equal to 1 times 10 to the negative 14th. And that happens to equal Ka times Kb. I'm not going to get into why that works. You can Google that. But just take my word for it. And yeah, a lot of times tests will like to trap you by giving you the Kb, but you need the Ka, and then all you have to do is use this formula, and then more points to you. So yeah, well, let's actually do a practice problem. Okay, so we want to calculate the pH of a 5 molar solution of nitrous acid, and this is not to be confused with nitric acid, which is a strong acid, and I have a video for that. So this is different. This is nitrous acid, which is weak. So we'll start off by doing an ice table. So let's first write the reaction. Nitrous acid is going to dissolve into H plus and nitrite ion. And we have our ice table right here. So as it states, its initial concentration is 5, and this is going to be 0. Then it's going to change by some factor, and here are the equilibrium concentrations. So we're given the Ka, okay, and we know what Ka is symbolically equal to, so we can solve for x. And why do we want to solve for x? Well, we want to find pH, and pH is, a measure of the H plus ion concentration, and the H plus concentration happens to equal x. So once we solve for x, we're good. So let's do this. Ka is equal to 4 times 10 to the negative 4th, and then that's going to be equal to x squared, or 5 minus x. And oh my god, there's a 5 minus x. We had to multiply everything out. Fortunately, we don't have to do that. X is going to be small, so we can just pretend that's not here in the denominator. So now we have a really simple problem that you don't really need a calculator for, but I'll take my anyway. Just give me a second to solve this. Okay, so yeah, I got x is equal to 0.044721. Now we just have to find the pH using the pH formula. So that's negative log H plus negative log that number, and then we're good. So let me plug that in again. Yeah, you have to be a real genius to do this in your head. And then you get 1.35. So yeah, that's our final answer. And yeah, so it's really not that hard. Let's do another one. Okay, hi everyone. Well, now we want to calculate the percent dissociation of a 1 molar solution of acetic acid. So yeah, I mean, they like to trick you by doing the percent dissociation, but in reality, we're doing the same thing, really. So what is acetic acid, first of all? Well, it's simply HC2, H3O2. And actually, you don't even need to know what acetic acid is. You just need to know that it's a weak acid, because you know it's going to dissolve into H plus and an acetate ion. So let's make our ice table. So that's going to be 1, that's going to be 0, that's going to be 0, that's going to be minus x, plus x, plus x. And here are the equilibrium concentrations. So once again, we know what Ka is, so let's solve this. X squared over 1 minus x. And we can pretend this x isn't here because it's really small. Now we just have to take the square root of that number. Give me a sec. Sorry. It's going to be about 0.004243. And then, yeah, so we want to know the percent dissociation. Well, to find that, it's really easy. We just divide the number we just found by the initial concentration. Which was 1, and then we multiply it by 100%, because, you know, we want percent. And that's going to give us 0.42% dissociation. So yeah, weak acids don't dissociate that much, apparently. So I hope you liked the video, and have a good night, or have a good day, and yeah.